And if you look on your paper, it's problems 105. I didn't write for some reason. 105 to 109. Do all of those. And then 111 to 120, all of those. So let me turn to 160. Okay, the first set of problems says explain the mistake that is made. So for each of these problems, you're going to go through, there's a graph, there's an explanation, and somewhere along the way they make a mistake. Your job is to identify where the mistake is. And at the end of class, we'll go through each of those to verify that you understand how it works. And then down here is another one of those sections of true or false statements. So you'll read the question and then say true or false. Go through all of those, and then on the challenge section is just more on functions, 117 through 120. So go ahead and start that. At the end of class, we'll go through and we'll verify your answers. Okay? If you're watching this at home, pause the video, work through all those problems, and then we will explain them together. So, number 105. What is the mistake with 105? It's not the horizontal line test. The vertical line test determines whether or not it's a function. What does the horizontal line test determine? It determines if it's one-to-one, and if it's one-to-one, then it is invertible. A one-to-one function passes the horizontal line test, which means if you invert it, it will pass the vertical line test. Okay, 106, what's the problem? You can't distribute a negative into a function. Why not? Are there cases where you can distribute a negative into a function? Yes. Are there cases where you can't? Such as this one. Okay. Why can't you distribute the negative inside? I mean, what happened with that? Why is that a problem? I mean, why in this case did distributing the negative not work? So if you type in -1, you get 3 times -1, which is -3 minus 2 is -5. If you type in +1, you don't get the opposite of -5. 3 times 1 is 3 minus 2 is 1. So it just gives you totally different answers by doing that. Okay? 107, what's the mistake? So is f of x plus 1 the same as f of x plus f of 1? Not even close. So that is not allowed. Okay, 108. Determine the domain, and they came up with -infinity to 3. What's the problem? What's that? The only problem is the bracket on 3. It should be a bracket on 3 because plugging in 3 gives you the square root of 0, which is a real number. Okay? 109. What's the mistake on 109? It's the same mistake they made on 107. you cannot split g of negative 1 plus h into g of negative 1 and g of h. 110, what's the mistake? Oh, you didn't have to do 110. Sorry. Okay, 111. If a vertical line does not intersect the graph of an equation, then that equation does not represent a function. Why? A square root graph has vertical lines that don't intersect, and yet it's still a function. So the vertical line test does not say it has to intersect exactly once. It says at most once. It can intersect never, or not in a particular place. Doesn't have to hit once, it just can't hit more than once. Right, 112, if a horizontal line intersects a graph of an equation more than once, then the equation does not represent a function. So we have a horizontal line that hits twice. Is that still a function? Yes. It's the vertical line test, not the horizontal line test. Now, if I invert this, will it be a function? No, because when I invert it, it will look like that, and then it fails the vertical line test. So if it passes vertical and horizontal, it's called a one-to-one function, which means that it's invertible and it is still a function. Okay, for x equals y squared, x is a function of y squared. If I just had that statement, is that a function? No, and when we say it's not a function, we mean that what we're saying is x is a, or sorry, y is a function of, nope, I'll get it, x, which means with x as my domain and y as my range, it is a function. So y equals x squared says the function y is written in the variable x, and yes, it's a function. Now, if I were to say x equals y squared, is that a function according to this statement? No, because it's a horizontal parabola which fails the vertical line test. But if I change the statement into this, is x a function written in the variable y? Yes. So that's the trick on this one. According to our old definition, we always say y is a function of x. But if you change that definition, then x equals y squared becomes a function. Okay? 114, for y equals x squared, y is a function of x. That's true. And that's the sort of function we normally deal with. Okay, and then the next two, they're not true or false statements. I don't know why they did it. But it says when you plug in 1, a times 1 squared minus 3 times 1, and it equals negative 1, what value of a makes that true? So you're going to add 3, and you get a equals 2. Okay? 116, if g of x equals that function and g of 3 is undefined, then what must be equal? So if x equals 3, we get 1 over b minus 3. What value of 3 makes that undefined? Or what value of b makes it undefined would be 3. Okay. 117. So we have f of x. If f of negative 2 is undefined and f of negative 1 equals 4, find c and d. Oh, sure, it had to go darker on me. So we know when we plug in negative 2, we get c plus 2 over d plus 2. If that's undefined, and when I plug in negative 1, I get 4, what are the value of c and d? Well, I know the value of d from here. D has to be negative 2. because negative 2 plus 2 would give a 0 in the denominator and it would be undefined. So d equals negative 2. When I plug in negative 1, that would be c plus 1 over negative 2 plus 1, and that equals 4. I get c plus 1 over negative 1 equals 4. What value of c makes that true? Negative 5 plus 1 would be negative 4 divided by negative 1 would be 4. So c equals negative 5. Okay, 118. Construct a function that is undefined at x equals 5 and whose graph passes through the point 1 comma negative 1. How did you do that? So start with that. So essentially you're saying a over x minus 5 equals negative 1 when x equals 1. So if I plug 1 in there, I get a over 1 minus 5 is negative 4, and that needs to equal negative 1. What value of a makes that happen? Negative 4. Is that what you got? Negative 4? Well, so, and you put that on top, or did you put it on bottom? And then, oh, I see. Okay, so this would work if a is negative 4 over x minus 5 satisfies that. Or you can take 1 over x minus 5 and figure out how much it missed by. You plug in 1 and you got 0.25, so we need to add an additional 0.75, and that will lift the graph up. And actually, I think those are the same. What does 0.7, 0.5 mean? I don't know. And actually, I think if you do a common denominator, those will end up... No, they won't. They're not quite the same graph. Okay. So 119. We want to know what is the domain of this if a is a real number. Just set x squared minus a squared equal to 0, and that's the only point that doesn't exist. And then 120, you just want to know when is x squared minus a squared greater than or equal to 0.